large number of sites early on were identified by scientists primarily as being of interest. And then those sites were evaluated by some of Jerry's colleagues in the Mission Planning and Analysis group, as well as some the Belcom folks at headquarters in terms of their accessibility. And then as each mission presented new information about the geology of the moon, they revisited the selection, gradually wintered it down to a few candidate sites for each landing area. And again, went through the process of determining not only could you land there, but what was the fuel cost of doing so, and how long were you going to be able to stay there, given the other constraints of the Apollo. Lunar module was very capable, but not that capable. And so a combination discussion started between the headquarters group, Belcom people, and Mission Planning and Analysis people. And they finally figured out that if we updated the state vector, that's the position and velocity of the spacecraft, just before powered descent into Tarsvik, that ellipse would shrink to about 1 kilometer, and so you could land there. And that interaction really made the difference. Otherwise, we would not have gone to Tarsvik. But it shows you the flexibility of the system. They were able to come up with a way to do that, even though we only had a short amount of time, because of the position of the site, the east position of our landing site, to update the state vector in the lunar module. I want Paul's view on this, but that would depend on part of what your payload to the moon is going to be on any given mission. Or are you going to land some unmanned capability and then go there with human capability? If you had the Saturn V capability, our mission put about 44 metric tons on a trajectory to the moon. If you had that, you'd probably, in order to take advantage of some of the new technology developments like pressurized rovers and things like that, well, you might use 2 missions each time, an unmanned and then a manned. And that's probably almost certainly something you're going to have to do on Mars. I think you're going to send unmanned supplies and habitats and stuff out first before you take humans. But having said, and the SLS, the Space Launch System that's under development at the Martian Space Flight Center now, is potentially capable of growth, I have been told, to 100 metric tons. If you can do that, then that changes sort of the dynamics of what I just said. The other thing I would say, for yielding to Paul, is that we would be able, I think, to collect more different data and collect it faster in the future than we were able to this time, because we collected samples now and then analyzed them back here on Earth. We have technologies now today that are going to make sample selection, I think, much more sophisticated than